So we've talked about slope-intercept systems of equations, and now we're going to talk about standard form equations. Let's take a look at pigs and chickens. A farmer saw some chickens and pigs in a field. He counted 60 heads and 176 legs. And so what we're going to do is we're going to problem solve this. I am your group. And what we need to do is we need to figure out that the number of pigs plus the number of chickens would equal a total of 60 heads, okay? Those are countable items, all right? Now, what makes pigs and chickens different? What makes them different is the rate of the legs, okay? The number of pigs times, how many legs do pigs have? 4 legs, plus the number of chickens times 2 legs would equal a total of 176 legs, okay? This is standard form. You have a countable total along with a calculated total. So P and C is equal to 60, and 4 times P plus 2 times C equals 176. And you can go ahead and solve it from here, and we'll talk about this tomorrow. Let's take a look at this one. This is another example of standard form. You have a total value of 580, and you have a total of 40 coins. Notice that we have dimes and quarters. Well, if you have dimes and quarters, they're going to use D and Q. The number of dimes and the number of quarters has to equal 40. So right away, bad choice, bad choice. Either one of these are possible, but then you have to remember the value. The value of a dime is equal to 10 cents. The value of a quarter is equal to 25 cents. And so to find the total value, it would be 25 cents times the number of quarters and 10 cents times the number of dimes. Bad choice here as well. So go ahead and pause the tape for just a minute and go ahead and read this and make a card for standard form systems of equations. Hope that you finish this up. This is important. Countable total, calculated sum. But be careful. Sometimes the rates are actually the number of objects in the group, and we'll go over that some more tomorrow. Or it might show a proportional relationship between the two groups. Some special problems show relationships between two calculated totals. So please make sure you have a card for this so we can definitely go over this tomorrow. So let's take a look at this. Nadia and Peter visit the candy store. Nadia buys 3 candy bars and 4 fruit roll-ups for $2.84. Peter also buys 3 candy bars but can only afford 1 additional fruit roll-up for $1.79. Remember what I said? Some special problems show relationships between two calculated totals. So let's see. Nadia's money equals her purchases, correct? Well, what was her money? $2.84. And what were her purchases? 3 candy bars, and Miss Rose is just going to call those bars, and 4 roll-ups. Okay. What about Peter's money? Peter's money also involves purchases. His money was only $1.79, and that led to 3 candy bars and 1 fruit roll-up. All right, now I know we usually use X and Y, but Miss Rose is going to use B and R to make life a little bit simpler. Let B equal the cost of a candy bar, and let R equal the cost of a roll-up. Notice at this point, take a look, I am looking for the rates. I'm looking for the rates, not the number of objects, because we already know through this that we have the number of objects. So in this special case, $2.84 is equal to 3B plus 4R's, and 179 is equal to 3B's and 1R. Now, I know you didn't have to write the 1, but you should be able to figure it out from here, and we'll talk about it tomorrow. Let's take a look at this one. This one is very, very important. In fact, I'm going to put a little star here because this has to do with tailwinds, okay? And it also has to talk about blowing in the same direction and going the opposite way, okay? You need to calculate the speed of the wind, okay? Now, remember, Mrs. Rose can't draw her way out of a paper bag. But let's think about this for a second. Here is Mrs. Rose flying her favorite plane, okay? When she has a tailwind, it is helping her. But when she has a headwind, it is hurting her. Okay? So, my rate plus the wind was helping me actually has 275 miles per hour. But my rate with the wind hurting me is only 227 miles per hour. Okay? This is a very typical problem. R plus W is equal to 275. R minus W equals 227. Notice that you have additive inverses, so you can go ahead and pause the tape and solve it from here. Okay, welcome back. 2R is equal to 502, so my rate is equal to 251. 251 what? 251 miles per hour. Okay, that's my rate. What is my wind speed? My wind speed is 24 miles per hour. All right, so let's take a look at this one. An airport taxi firm charges a pickup fee plus an additional per mile fee for any rides taken. The 12-mile journey costs $14.29 and a 17-mile journey costs $19.91. Calculate the pickup fee, the per mile rate, and the cost of a 7-mile trip. I want you to go ahead and do this one for tomorrow. All right, Paul has a part-time job selling computers at a local electronics store. He earns a fixed hourly wage, but can earn a bonus by selling warranties for the computer he sells. He works 20 hours per week. In his first week, he sold 8 warranties and earned $220. So let's see. He works 20 hours times a fixed rate, and he sold 8 warranties to make $220. In his second week, he worked 20 hours again at his fixed rate, and he sold 13 warranties to make $280. Okay, so we're going to let R be your rate, and we're going to let W equal the number of warranties. So 20R plus 8W is equal to 220. 20R plus 13W equals 280. Here's a hint. Simple elimination. Whoops. Good thing I have the handwriting of a serial killer, huh? All right. So, finally, pause the tape and take a look at these websites. These websites are excellent if you want to talk about standard form of linear equations and solving by elimination. Toodles. See you in class tomorrow.